In example 2.1g, we'll be looking at another radical equation like we did in part F. This is going to be y equals x to the 1/3, very similar to x to the 1/2, and we would interpret this as being equivalent to the cube root of x. Rather than it being a square root, this becomes a cube root. Now with a cube root, we don't have the same issues like we do with the square root. So actually, your domain here is going to be all real numbers. We are not going to have any issues with that. So we'll use an all real number domain given by the equation f of x equals the cube root of x. And of course, I'll write that down. This is the cube root function. And for making a table, you can make the table using, again, any real number that you want. However, it would be wise if you used some nice values. I say nice because they wouldn't require you to have to use a calculator. For example, 8, or I start with -8, -1, 0, 1, and +8 are all going to be really nice values. And when you take the cube root of -8, you'll end up with -2. Cube root of -1 is -1. Cube root of 0 is 0. Cube root of 1 is 1. And the cube root of 8 is 2. And you'll find that that is going to be really kind of the opposite of what you had with the cubic function. The two columns, if you look at the cubic function, the columns that you had for x and f of x there are actually switched. And that goes back to the same kind of similarities that you have in the squaring function and the square root function. So when we plot these, we should get something that is very similar to the cubic function. And it is similar. The first quadrant will have a curve that looks a little bit like the square root function, but it also has a third quadrant that goes with it. So we'll connect a curve there as well. And should be a little smoother than that, but this is your basic cube root function.